All right, 5.3, solving rational equations. The first thing we're going to do is review excluding values. So we're looking at our restrictions. Remember, our restrictions come from our denominator. So on this first one, our denominator is 7x minus 21. We're going to say that that cannot equal 0. So if we want to solve that equation, we get 7x cannot equal 21 when we add the 21 to the other side. So x cannot equal 3. And then on B, looking at our denominator, we just have x. So x cannot equal 0 is our only restriction. All right, so when we solve equations with rational expressions, we're going to do the same thing we did at the beginning of the year when we were solving equations with fractions. So this first example is going to kind of review that. We want to start by finding our least common denominator. So looking at our denominators, we have 4, 4, and 6, and we're looking for the smallest number that they both multiply up to be, which is called your least common multiple. Between 4 and 6, we get 12, because 4 times 3 is 12, and 6 times 2 is 12. And the way that I recommend we solve these is we're going to put a 12 above every term. Then we're going to divide. So 12 divided by 4 is 3. So we're left with 3 times x equals 12 divided by 4 is 3. So we're left with 3 times 1 plus, then divide again, 12 divided by 6 is 2. So we have 2 times x, or just 2x. So if we rewrite this, we now have 3x equals 3 times 1 is 3 plus 2x. Solving, we're going to subtract 2x from both sides to move x to the same side. So we have 1x, or just x, equals 3. If we go back and look at our LCD, we want to make sure there's no variables in it, which there aren't, so we have no restrictions. So x equals 3 is our solution. Okay, going down to B, 1 over x equals 1 over 5 plus 3 over 2x. So again, starting with our least common denominator. So we have an x, we have a 5, and we have a 2. We don't need to list this second x because we already have an x listed. So x times 5 times 2 equals 10x. From here, we can state our restrictions. So if 10x cannot equal 0, dividing by 10, we know that x cannot equal 0. And then we're going to take our LCD and we're going to, again, multiply it by every term. So I'm going to just write it above each term. And then we're going to divide, so that way we can get rid of our denominators. So 10x divided by x, we're just left with 10. So then we have 10 times 1 equals 10x divided by 5 is 2x. So we have 2x times 1 plus, then we have 10x divided by 2x, which is 5. And we're taking 5 times the numerator of 3. Simplifying, 10 times 1 is 10, which equals 2x times 1, 2x, plus 5 times 3, which is 15. We're going to subtract 15 from both sides. 10 minus 15 is negative 5, which equals 2x. Then divide both sides by 2. So x equals negative 5 halves. That fraction cannot reduce. And then we want to check. We got x equals negative 5 halves. We said at the beginning our restriction x cannot equal 0. So can x equal negative 5 halves? Yes, it can. That is our answer. All right, now over to C. So now we're going to get more binomial expressions where we need to do some factoring. So we have 3x over x squared minus 9. X squared minus 9 we can factor. So I'm going to cross it out. And I'm going to rewrite it as x plus 3 times x minus 3. And we're going to state our LCD. Our first fraction, we have a denominator of x plus 3, x minus 3. Our second denominator is already factored, x minus 3, which we already have listed. And then x plus 3, which we also have listed. So we're now going to take our LCD and we're going to write it above every term. And then we're going to cancel. So x plus 3 times x minus 3 over x plus 3, x minus 3, everything cancels. So we're just left with 3x plus, looking at our second fraction, we're looking to see what can cancel, and that's going to be our x minus 3's. So we're left with 1 times x plus 3, which equals, then we have our x plus 3 on the top and the bottom, which are going to cancel. So we have 3 times the quantity x minus 3. Now we have an equation with no fractions, so we're going to solve like normal. So we have 3x plus x plus 3 equals, distribute your 3, and we get 3x minus 9. Combine like terms on the left. 3x plus x is 4x plus 3 equals 3x minus 9. Subtract the 3x to the left. 4x minus 3x is 1x or just x plus 3 equals negative 9. To get x by itself, we're going to subtract the 3, and x equals negative 12. All right, going back up to our LCD, one thing I forgot to mention, what can x not equal? From our LCD, we know x cannot equal negative 3 and positive 3. So now the question, can x equal negative 12? And it can. It's not one of our restrictions, so this is our answer. All right, and the last one, 8x over x plus 1 equals 4 minus 8 over x plus 1. Nice thing about this problem is that we only have one denominator, so our LCD is x plus 1. Let's go ahead and state our restriction. If we have x plus 1, we know x cannot equal negative 1. We're going to take our LCD, and now we're going to multiply it above every term, including the 4. Just because it doesn't have a fraction doesn't mean we don't need to multiply it. It just means nothing's going to cancel. So our x plus 1s in this first fraction are going to cancel, and we're left with 8x equals, nothing cancels in our second term, so we have 4 times the quantity x plus 1. And then our x plus 1s cancel again, So we're just left with minus 8. So if we distribute, we have 8x equals 4x plus 4 minus 8. Combine like terms. So we have 8x equals 4x minus 4. Subtract the 4x from both sides. 8x minus 4x is 4x, which equals negative 4. Then divide by 4, and x equals negative 1. Now, we need to check our restrictions. We said at the very beginning that x cannot equal 1, but that's the answer we got, which is a problem. This means it's an extraneous solution, or more importantly, we have no solution.